Good afternoon, everybody. I'll try this out here and try a different approach. See if this shows up here on my computer. That way I can kind of watch and do things a little different. Try that here a little bit and see what's going to go on or what's going to happen. Just sitting there picking up some tools, guys, so bear with me here. Like I said, apparently my, there we go, now my computer's moving. Picking up a little bit of the mess here from earlier. I've been stopped a million times today just trying to get the most simplistic of things done. So, anyways, how's everybody doing today? See if I can get some of the crosstalk here off of it. I'm supposed to have muted it. There we go. Anyhow, yeah, I've got the pallet started. I'm actually going to stop for a minute on the pallet. I'm going to go ahead and set the power modules and get those taken care of. And then we'll come back and finish up this. So this won't take too long, guys. Let me grab the other module here. Live feed. So far. And looks like Mr. Anthony, I see you're in there, buddy. Yeah, Facebook makes life a little easier on some of that. Had to get me a drink too while I was at it. Alright. One more trip over here. It has just been a madhouse today. Alright. So one of the things that I'm noticing is there's definitely lag time from the computer over to the device I'm streaming off of, which I figured I would try my phone. Xfinity has been working on my internet yet again. I don't think they're ever going to get that thing figured out and fixed. So, now that I've got a lovely lag time, I get to wait and see how things are going to run. I think everybody can see everything okay pretty good right there. Just trying to figure out the limitations here of the camera. Well, thank you, Mr. Black. Like I said, this one's going to be kind of interesting. This one's going to have biasing added to it as well. Hopefully you've been doing all right. I haven't seen much of you here lately, but I know you've been kind of busy. Anthony, hopefully things are going good on the home front with you. I know I spoke with you here just a few days ago. What you've got going on. I'm going to go ahead and remove these covers. That always get in the way, guys. Yeah, well, I've been pretty busy. Of course, I've been hurting kind of bad here lately too. So, just got through talking to one of the guys over there in the islands, one of the big strappers, about his Cobra 2000. That's going to be coming up here, hopefully yet this weekend. I've tried to get back on this since like 9 o'clock this morning, guys. It's been that crazy around here. But anyways, plug that in. I'm going to actually show you guys something that I'm also going to be using. Not a lot of people use this, and it's kind of interesting. It's actually heat sink plaster, and I'll show you what I'm going to use that for here when we get just a little further along. Let me grab something because I want to put a load on this. I'm going to grab a load resistor. Do you have a question for me, sir?
Nope, same thing happened this time.
Same thing, huh? Okay. I'll give it here and let me take a look at it.
You need to be putting that on your feed.
Well, sure. Everybody wants to see me tear down a Honda carburetor and, put a 1000cc engine down inside this amplifier.
Oh, that would be a fucking trick and a half.
Yes, it would, guys. Yes, I am taking a hammer to the carburetor.
But only because it's not yours.
Absolutely.
I see how you are. Friends like you.
Uh-huh.
I probably wouldn't get out of anything if I didn't have them.
I worked on the last carburetor I worked on just a little bit ago, guys, so yeah. Like this has absolutely everything to do with what we're working on today, right?
So... Last time you used a little bit of that sea foam and that other stuff to almost spray yourself in the eye.
Mm-hmm. Alright. Alright, so what you're probably going to have to do is take this probably to the garage. And right in here, stick the air hose to it after it's pumped up. And it should be able to push, then it should push that right out forward.
Oh my.
Since that doesn't want to exactly come out. Because if the light tapping action doesn't work, and we know it's loose, it's probably what you're going to have to do. And yes, this thing is running like really slow, guys. Way behind.
Lagging real bad.
That is off of a Honda Davison, 1979 Honda Goldwing.
Why must you do me this way?
So back to the project that we're actually working on. I got one of them apart for him. So we've been working on motorcycles today. Now, one of the things that I'm actually doing here, guys, is we're actually going to induce a very, very small load. This is just a 3-watt resistor. It's 270 ohms that we're actually going to put across one of the positive and negative points on this. And it doesn't have to make super contacts, it's just going to make contact. And what that will do is that'll actually draw it down just a small insignificant amount. Okay, by doing that, what that's actually going to let us do is actually see a nice smooth voltage. There are 15 million screwdrivers, and you'd think I'd be able to grab the right one first time. I'm going to adjust these up to 14.50. That's our target number on this. Okay, 14.502. Now, as I was saying earlier, I've got the silicon heat sink plaster, and that's actually what we're going to be using. Heat 3. You gotta love that typo stuff. No, I think it's a generic Cooney, I think is what that was. Alright, well anyways, back to what we're doing. Okay. I'm going to put just a small amount of that right there in the corner of our variable resistor that we use to adjust the power supplies. Now, it'll take about 30 to 45 minutes for that to actually cure, and it can actually be take a pick and pick it back off if we want to actually set that at a later date. So since we've already got a reference point, which in this case is 14.50, and technically it's 2, so that's what I'm actually going to write on the top of that. And what's nice is if you actually set these, truthfully, anytime you do a set of these, you actually want to do them on the same day, because believe it or not, your line voltage your line of voltage can actually adjust or affect how you set these. So if you've got a significant number of these, make sure that you can take time to actually sit down and do them all at the same time whenever you're actually setting the voltage. And the reason why I say that is because 1 to 3 volts difference on your AC line current uh, actually does change. Now, not a lot, but it will change. It can change the output of your power supply, but about as much as 2/10 of a volt, which is not a significant change. But whenever you're looking at putting 6, 8, 10, 16, 30 of these modules together to create large power supplies, that imbalance can actually cause you problems later down the road. Now, that's one of the things that I've noticed as far as with some of the different power supplies. And around here, I've noticed it more in the last 6 weeks. I've noticed it more so than any other time. And part of it has to do with the fact that right now our county has been making some major changes on the substation that feeds our little area. So we've had some blackouts, we've had low voltage, we've had just a mixture of different things. So I wanted to kind of make that aware of you guys, or make that aware to you, that anytime you're messing with some of this, take note. Somewhere in the ancient archives, I actually used to have a meter that I plugged directly in here that you could actually set up. It was very popular back in the 70s and early 80s, where they actually had a line current meter that you actually would set on your desk. Because of where so many people use the old sweep tube amps. So it was a very, very popular item back in the day. You can actually make one yourself just by getting a project box. And typically you can always find a AC meter that you can wire up into a small project box for not much money. But it's actually important just to know what your line voltage is, because that'll actually differentiate why you've actually lost power on an amplifier. More so on the tube type, because of the fact that they use a floating power supply. Yeah, right, early. Yeah, Loctite on the pill screws. Oh my God. Sad part of it is, buddy, I've actually seen that happen. Yep. Essentially, it was just short of being destroyed. Because of that. Alright, so we'll turn the switch back on. Resistor down in there. Well, I don't know if you guys can see it in the camera or not. I've got a visitor in here. He's over there on the wall over there next to the chart. I have a little lizard friend that has came in. Oh, he's already moved. I'm going to show you guys. Let's bring this up just a little bit more. He might come back in. Right above where the pliers are you guys will watch, I have a blue lizard. So anyways, let's go back and double check where we're at here. Yeah, oftentimes I'll take these apart as well, and I'll change that out to a 10-turn potentiometer. I bought a bag of like 200 of those off of eBay. I bought them just for this particular purpose. Because it makes life so much easier to set these. Alright. Of course, if I move real fast, I know he'll leave too. Now the little lizard, he's on the back wall. So he's just making his way around. Hello, Don. How are you doing, buddy? Mr. Shade Tree. Yeah, Boot's finally going to get him a brand new amp. Yeah, he's talked about this for well over a year, and he's threatened it. Finally decided to get him one. So we'll leave that out because I'm going to need it here in just a minute. Oh, and if you decide to use a load-bearing resistor when setting these, whatever you start with, make sure you use the same one throughout the entire process. That way you get an exact amount on each one of the supplies as you're putting them together. Yeah, someday when my rich uncle gets out of the porterhouse, I might actually get a little more equipment in here where I'm gonna have a couple of different cameras going at the same time, and might actually get a computer that'll actually be fast enough to handle some of what we do in here. 14.502. I think that's going to be close enough. Good. Well, the easy part's done, guys. Yes and no, Mr. Black. It does, but more importantly, it ensures that those can't move. Especially, like for example, if this was to be shipped from one place to the other. Um, you know, if you're using something like the single turns, which, like I said, if I'm building something large, I'll actually pull all of them apart and I'll replace those with a 10-turn potentiometer instead of a standard. Just for example, essentially what we've got there's different styles of 10-turn potentiometer. Okay, this is just a single turn that's right here. That's actually what's in most of the supplies that you're going to have. And when you're literally splitting hairs on voltage, these are very, very touchy. So just a slight amount of movement can change it by 2 or 3 tenths of a volt. Not that that's that big of a critical deal if it's just a single, but in stacking these, it can be very, very detrimental. Now the other style, now like I said, they've got a vertical version. This is an elongated one, which I use it for 1 or 2 different purposes here in the shop. But this is another style. But this one, you actually can turn that screw instead of turning it a single full turn. These actually have 10 rotations. So as it goes along on the inside of here and goes up and down, it actually can go 10 turns in order for it to go from one extreme to the other as far as on the wipers. So like I said, much more precise, especially if you're, like I said, splitting hairs. I usually don't worry about it. Usually if I'm running 1, 2, or 3 supplies, much more than that, I do go ahead and go through the hassle of pulling those out and replacing them. Yes, sir.
It's got me whooped.
It has you whooped, huh?
Mm-hmm.
All right. Well, at this point in stage, you're probably going to have to wait on me or go to the next section of your project.
I'm thinking I'm probably going to skip that one on this one and just reuse it.
You can do that. Yeah.
But I figured I'd let you know that
Sign language? Yeah. Hey, we can do that too. But anyways, guys, yeah, like I said, some of the differences in the different potentiometers, it should still be all right as far as on the boil out for that.
I'm just saying, you don't blow into the side over here.
Mm-hmm.
It doesn't do anything for this.
Did you blow in any of those?
Yeah, you blow into that one there, or that one there. It pushes it out.
Okay.
But you have to cover up these holes down here.
Okay. Well, then you learned something.
Yes, I did.
So.
Didn't work, but did
Yep.
learn something.
Well, that's okay. We'll get it figured out later.
It may come right out once we set that.
It just might. Alright, so Let's get these out of the way. Still dealing with carburetor questions. Alright, so we've got those loose. Show you this. So we're going to go ahead and tighten down the rest of these, that way we know that they won't pop out. And I'm removing the ones that essentially are going to be of no value to us. And the reason why I say that is because I'm going to use a positive and a negative. The only ones that are actually going to be, we're actually going to use these screen terminals on is going to be our line voltage in and our neutral. The ground here, I'm not too concerned about that. The reason why I say that is because if you actually test this, let's pull our probes back down and I'll show you. And I know that this is one of those where everybody's different, and I used to use those, but it's a lot of extra wiring for really and truly nothing. Alright, so right there is our tone to let us know that there's contact. We're going to go right here on our ground strip here to the side of the case. So that's the reason why I don't use that. I usually just go ahead and bond the case with the ground wire, and then since these are actually going to be physically bonded with screws, I don't use double-sided adhesive tape like I have seen in some of the different ones that have came in. I actually use physical screws. So let's set that off to the side. I'm just trying to get some of the hard, or not necessarily the hard stuff, but the bulk stuff out of the way. Then we get back to the fun stuff. Set this off to the side. We're going to grab the case that I've been working on. So that's what we've got, folks, that we're using. It's actually a 16 pill case. Try to get some of this cabling and stuff out of my way and out of the shop for you. Let's see if we raise up the tripod a little bit. Mr. Black, that's a really good question. Typically on like on two modules, as far as on the small, the small ones, whenever you've got just a few of them, there's actually a couple different methods going into that. Now, when you've got, for example, here a while back, excuse me, I built a I built a 16 or a 500 amp, and I used 16 of these switchers. Now, in that particular case, because of the fact that you've got so many doing so many project or so many things, yes, actually it does. The AC, you're only talking about milliseconds because of the length of the wire and the current. But those milliseconds actually do make a difference. Now, when you go into something small like this, there's a couple of different methods that can be used. You can do parallel as far as on the lengths of wire, and what I mean is symmetrical in length. That's one method. Now, the other method that you can actually do is do a crisscross method on smaller ones like that. Since you're only looking at about 15 amps of current at a maximum current draw on three supplies, what you can actually do is daisy chain your neutral and daisy chain your positive across your terminals. As far as here and here, you can actually daisy chain them and then hook, for example, the neutral. You can hook it up on your first one, come back and hook up on your line voltage all the way on the opposite end. And there again, it is a symmetrical draw between the two of them, because of the fact that you are placing one point to the other. So essentially what you've got, and you just have to imagine this in threes, like three made. For example, you would hook your incoming power here on the line and your neutral over here, and that actually will stabilize and actually do that. Some people do use that method just because of the fact that it cuts down, and they're not actually going to have as much current or as much wire involved. I've seen that done on people who use 4, 5, 6, 8 of these based on what they're doing, and that makes me leery. I've seen it run, I've seen it work, but it's really not the best method. Like I said, whenever you're doing small amounts, because of the fact that you don't have a very long length of travel, for example, doing four or six of these together, that's where you really get into some stuff that it really gets kind of scary in relationship to that. Now on this one, because of everything, I'm actually gonna take all three of the input lines. Now they're all going to be symmetrical in length, going up to my breaker switch that I'm going to be using, and then on the neutral they're all going to be the same length, but they're going to be back here. So they're actually not going to be the same length as what the line is, but it's still going to be the same, if that makes any sense. Just like on your hot and your ground, you can get by with shorter on one side or the other, but if you're using, let's say, 4 inches shorter on the negative wire versus the positive, that's perfectly fine, but all the negatives must be the same length, all the positives must be the same length in order to go ahead and have the current the correct amount as far as current distribution and load. Question?
I'm just letting things ferment a little bit longer before I switch over to the other one.
Okay.
I can really fit.
I didn't know if you were using bandwidth or not, so because I know my computer has decided to slow down and quit moving.
Oh no, I'm on LTE.
Okay. So anyways. So I'm gonna halfway line these up to where they're actually gonna be at. And the only reason why we're doing it this way at the moment is I want to get my length of wires to go from point A to point B and vice versa. So just set those in there. And I am going to be using parallel lengths of AC wire as well, by the way. Mainly because of the fact that, it's going to make my life a little easier on this particular setup.
Desk.
Is it right there by the mouse?
I know, I'm trying to chase him into the shot.
Yeah, he's over the sorry. Yeah. Hey, buddy. Yeah, he's been on the back wall. He's been over here. He's been just out of the camera.
Yeah, and he's staying that way too, jerk. He's supposed to be my fan.
Alright, so hopefully that takes care of my issue where I can see what's going on the screen here. Alright, so we got that taken care of. You are streaming just fine, okay. Alright, so there's that. Alright. Now you can kind of see the difference. Our gray is actually going to be our line voltage in, and our white's actually our neutral. And you can see the difference in the length of wire, but like I said, it's all actually going to be symmetrical as far as on point to point for the inputs. Set those off to the side. Let's go ahead and finish cutting our wire. I'm going to drop the pallet down in there for the moment. There's a
How long do you think I should leave that for?
At least 1 hour.
Cool. I'll set me a timer and decide tonight.
Yes.
That way I'm out of your hair.
Mm-hmm.
And I can have nice and soft things. And was that your tea or mine?
Better be mine because that's what I've been drinking on.
I'm sorry.
So, all right, let me grab the other wire for what we're going to be using for a DC.
I don't think I got the cables.
Takes care of our hot. What do we got here? All right. Well, still no new comments. I don't know if that's a good thing or a bad thing. All right. This in neutral. Add about 1 extra inch from what I think I see. Takes care of that. Oops. Okay. Let's see how close these are. There again. It's not a necessity, but ironically enough, there's probably less than a 30-second difference between the positive and the negative. Now what I'm actually going to do is I'm actually going to stack. I'll show you here in a minute. We're actually going to stack the negatives along this side rail and hook our positives up across the back. Of course, we've got to put our chokes and everything in, but we're not too concerned about that. Like I said, we'll get to the good stuff here in just a minute. Set that back off to the side. Well, Mr. Adams, what are you into today? Hopefully you're in there working and actually doing something besides trying to pick on me. Yes, I know they've got wire strippers. I've even got them out in the other building. But I have used side cuts for stripping for so long. Honestly, I forget about them. Yeah, this part here, guys, is about like watching paint dry, stripping the wires, but unfortunately it's a necessary evil if you want to finish the overall product. So third time is a charm. Pick it up for the third time. Chasing a glazed donut. Good afternoon, Tommy. got done with that chore. I know it may sound silly, and I'm not sure how well you're going to be able to see that in just a sec. But if you'll notice, I'm putting these all on the left side of the screw. And the reason why I'm doing that is that way, actually, as the screw is tightening, I'm actually taking the wire, not only am I clamping down on it, but it's also pulling it into it. It's pushing it away. So it's actually important whenever you go to put these together like that, on any kind of an electrical terminal that's DC or AC, you actually want to pull that into it and not push it away. That way you always know that your connections themselves are sufficiently tight, and you're not going to wind up backing one out unmistakably. Turn the heat up just a little bit more. And she's almost ready. Okay. A little tug, make sure those are all good. And we'll go to the next. No, I am far from that. I don't save my wire clippings. Now, I might save my solder snippings, but not my wire clippings. The reason why I say solder clippings is, if you're real good, you can take your solder. For example, if you don't like something that small, or you got problems burning your fingers, put them back together and keep using them. Alrighty. And to the next wire. Well, you've never seen anybody take solder and put it back together so that they can reuse all their little snippets? And as tight as what you are, I figured you were gonna ask me to mail you the leftover snippets that I have. Wake up, Mr. Black. Don't go to sleep on me, buddy. I gotta have more than early for commentary here. Cobalt. Tell you what, these are a little on the heavy side, but I like these just as good as I do the snap-on ones that I've got out in my other box. These things are great. Especially with an unconditional warranty. You can't beat it. Alright, so got that done. Now the other thing we want to take a quick look at before we go to the next step on this is check to make sure that all our color codes are the same. Believe it or not, I have seen, and I've even done it myself, where I have flip-flopped wires. So, it's important to go ahead and double check your work. We know we've got gray, we've got white, we've got all our blues together, and all our reds all in the same location. So we know we're golden across the board on that through. You need to see that again early. If somebody takes a little snippet, puts it back together. Just like that. Yes, they are. Yes, they are, Tommy. There are certain tools. I work for Lowe's Corporation here, right around the turn of the millennium. I worked for Lowe's for several years, and one of the things, whenever I helped to open a new store, it was quite interesting because we had different reps come in, and at the time when they first started out, and now I believe either Proto or Mac is now producing the tools, but in the very beginning, when they brought out the Cobalt line, they were actually being produced by Snap-on. They would change. If you look at a lot of the different tools that they have available at your local Lowe's, and do a comparison against them, they're actually being manufactured by one of the top companies. So the tools that you get are actually really good. If you go in and actually do some reading and research, it'll tell you that even if I was to take this screwdriver, turn it into a horseshoe, and then inside out, theoretically I am supposed to be able to take that back into the store, get it replaced with absolutely no questions asked. Which, of course everybody else had asked and wonder how you did that too, but yeah. You can't do that with Craftsman anymore. Craftsman, they question everything. Based on what store you go to anymore. You'll see that quite often. Alright, so set these off to the side. I'm going to get the screws. We're going to get the case. We're going to get those set down in there, and then get to the fun stuff. Yeah, Yeah, it's sad that there's so few things anymore that are made right here in the U.S. for us. Ah, wrong set of holes. Alright. While I'm doing this, I want to show you guys something else too.
You have a phone charger right now.
Do what?
You have a phone charger right now.
No, why?
Mine don't have problems with it won't work.
I've got one in the car. Plugs into 12 volts. You may want to check and see if Dwayne has a spare one, or there was one on top of the, or on the the end table by the TV, or where I sat on the couch. Alright, so these are both actually the same size screw. They're both a number 8. And I'm sure you guys are going to notice a difference in the size of the head. This is a standard pan head. This is what they call a truss head. What it is, it's just a larger head with a larger footprint here on the back side. And I really like using these, especially whenever I'm mounting power supplies. The reason why is because of the fact that it actually embraces and spreads the distribution of the weight further out on the head of the screw, and you're less likely to actually pull through like you are a truss head, where you've got like a 1/16 of an inch. Here you've got nearly a 1/4 of an inch. That puts the stress further away from the actual hole. So kind of wanted to point that out. Like I said, in shipping, it makes a huge difference. Well, tell Amy I said hello to her as well, Mr. Adams. Get that one mounted. Let's go ahead and get these buttoned up together. The reason why is because we're actually going to lay this down inside this channel that's going to be created because of the fold over. Looking, I don't see where my crimping tools are. Alright, so since I can't find the ones that I want, go with a different method since we're going to be soldering these anyways. Just another type of hydraulic crimp. Never matters whether it's the first or the last. There's always one of them. Never seems to want to go just right. right. Mr. Adams, are you ready to start on your big project? I know you've got your hands full over there with power supplies and a couple of amplifiers to build. There we go. Got that all squared away. If I thought about it, I put those on before I'm out of the power supply. Just a small little ferrite. Since our wires are so short, plus there's going to be a ferrite on our B plus going to the transformers. We're actually going to put these back here by the actual transformer or the power supply modules themselves. It's not a necessity to put them right there at the same point. So, and if anything, this actually works out a little bit better when you do it this way. I know some people would think that I've mounted these power supplies upside down, and I actually did it for two reasons. Number one, I've already switched these over to 110, which that's all this box will ever really and truly need is 110. The second reason is it puts my AC down actually close to the physical base and keeps my DC wires up and further away from my AC input. So that's the primary reason why I did what I did on that, guys. In case any of you had caught that. Alright, so get connector for that. Looks like I'm out of them in here, so I'll have to go to the other building. So we'll move on to the other portion of this. Can do those. I know I've got the rings for that. Well, it's about time you do something. Hello, James. Yeah, you need to get that order put up, big guy. That way you can. That way I know what I can get from you whenever I need it. Yeah, somebody needs to message me, by the way, before or after this video. Reason why is that way I can take all these clippings, put them in a baggie. That way I can send them to Early. Yeah, he and I joke around a lot, guys. On and off the camera. Kind of a unique. Yeah, relationship. You know, we definitely like to joke around and cut up with each other on different things. Where the hell are my Klein crimpers? Well, I'm wondering if one of the kids did not by chance borrow those, because I've got pretty much a place for everything in here, even if it doesn't always wind up in its place. It's usually very, very close to it, so I guess we'll wait on that. Set that off to the side, and we'll go ahead and start doing some of the fun stuff. Yeah, kids borrowing tools, no way. Yeah, yeah. If it's something that they think they need, yeah, they love to borrow. But yeah, for whatever crazy idea, it's kind of a novel idea if they'd actually bring them back. All right. That would make sense. Yep, just make too much sense. Just like I'm wondering, since the boy's going to attempt to rebuild 4 carburetors on a motorcycle that he's never worked on before, that should be entertaining. Of course, it's been entertaining for me because that's all I've gotten done all day is answering questions. you know, you know, does this go here? Does that go there? I don't know why, but every time that the kids and I have to ask them if they've borrowed XYZ tool, for some reason the infamous voice of Steve Urkel pops into my head. Did I do that? Oh, and if any of you guys work for Mac Tools, um, I'm always up for new tools. Mac and Snap-on are one of my favorite guys. All right, so let's do this. And we'll get back to winding this. whoever says winding a choke is easy, believe me guys, some days it is not as easy as it looks. Especially if you're trying to stay with something symmetrical. How easy it looks. He tried teaching you symmetry. Yeah, power chokes are actually one of the easiest things to wind. That's the easy part. The hard part when you're doing this is actually sitting back and doing like the combiners, which I took down that video. I'll reshoot it at a later date. There was a lot of issues and typos and all kinds of stuff, so we're going to redo that one at a little bit later. But yeah, the symmetry of putting together, which this isn't going to use it, but I'll show you one. This is where it gets more complicated. Now this is a 4-way, which I used 4 different colors for this one. And the reason why I did that was so that people could actually see each individual winding as far as on how it's actually accomplished to make life a little easier. On occasions, we'll have like this one here, where it didn't quite seat in there just right. Trying to do symmetry on something even as simple as that, that gets kind of crazy when you go up to the 5, 6, 7, 8 port, which I don't think I've ever built a 7. Usually it's 5, 6, and 8. Yeah. Those get pretty hairy. Yes. Yes, exactly. Yeah, and that could go into an hour-long discussion just talking about phasing. I think that's where Luke, kind of knocks it out of the ballpark. He's a little bit better. I shouldn't say a little bit. He's a considerably better speaker than what I am. I tend to get hung up in the middle of different things whenever I'm talking about different projects. It's just like if I was going up to a number 14 gauge wire, which I actually do have some hanging on the wall, I can actually use a single 14 gauge to feed each 2-pill section. But in this particular case, I like to do things a little different, so I'm actually using 2 16 gauge wires to feed each transformer in order to go ahead and establish my plus going into the transistors. It just doesn't want to work. What will is using the weight of the pliers. Since this one's not quite as tight, we'll have to just pre-tin those and then slightly hold them together. Okay. Sounds like I've got a little skip rolling, guys. I'm trying to. Well, you're welcome, Mr. Black. Like I said, I get several calls throughout the day from different people myself, asking questions and what have you, and of course I do the same. Let's see. This side's not got quite as much corner, so we're going to add a little more solder to that side. See if we can't do a little something different here on that. How's the carburetors looking?
I haven't pulled one out yet.
You know, you should be sleeping.
I know. That's kind of what I come out here for.
What, for me to tell you to go to sleep?
No. Tell me where to put them things while they're
In the garage?
still not cured.
In the garage. You know what a set of line crimpers are?
Line crimpers.
Or crimping tools for, butt splices and stuff?
Yeah, that pair that's outside.
Yes, I need those. And I also need, if you could go to the garage and get me a couple of the yellow butt splices.
Okay.
Out of the garage, out of the other cabinet.
Those are the ones that just go wire to wire.
Yep, end to end, wire to wire.
I don't know if you have any, but if you do, I'll grab them.
Yeah, if you would, I'd appreciate it.
I don't even want to try to fit that second one. It's all apart.
And if I remember right, we just had that discussion. And imagine that. My crimpers are outside. All right. Something a little different.
Not heard anything. Do we even clean it over when I do it?
No, absolutely not.
Okay. I'll take that first one out. Do we have like a box I can put that in?
Yes, and there's one that's partially folded there, or you can go and get out of the packing stuff, but that should work because that's a little bit larger.
Hoping to find something used.
For the price that those are, you can't beat it.
Yes, you got them $3.99.
Yep. By the way, did you ever find my crimping tools?
Yeah, they're out there.
No.
The red handle thing?
Yes.
Yeah. I'm gonna bring that in and probably make what's first.
Oh, okay.
And made it out to the garage. I can grab that carburetor and stick it down in here. Get that all done in one go.
And let's grab the other mouse. I love this one computer, guys. It's so slow, but that's the one I've been reading comments off of. One day over the rainbow. All right. Yep. Put them back after using them. Okay, let's move that microphone out of the way. Our keying circuits. And we're going to need some wire. Why? Because we are going to put a delay on that. Alrighty. Actually, let's use a different color. Huh, I'll have to look that up too, Mr. Black. Good. And I know I probably have a little bit of waste here on this, but in this particular case, it's going to be a little nicer because it's easier to solder this stuff on while it's outside the cabinet than it is inside the cabinet. Just a moment. Why? Because we have to have a third. Maybe even a fourth. All we're doing is just a light, loose braid, and essentially all it is just to help hold the wiring in place. It's nothing else. We don't want to do it real tight because we're going to lose too much on our overall length. And then when I put the diode on the relay, I actually left the wire sticking out just a little bit to make my life a little easier for when I went to install a keying circuit. Okay, so there's that. take care of everything we need for the keying circuit to actually function, except for the input signal. Get that taken care of. Now we're going to drop some 2879s down in this little girl. Any luck? Oh, awesome. I'll just put those in the connector door then. Yay! My climbs. They returned.
And you
Hanging
already
up
had
here.
some of those in here already, right? I may be only firing on one cylinder, but it's the funny one.
Speaking of firing, you're fired.
What did I do?
You didn't bring me a sandwich.
I didn't bring you a sandwich.
Yep, it's getting lunchtime. I think.
We just had lunch like an hour ago.
Well, absolutely not.
Maybe 4 or something. I don't know.
Anyhow.
Time is an elimination.
Yeah, exactly.
Now then.
Let's see. What did I miss here? Yeah, every so often, guys, I have to go back and reload the computer for some reason.
By the way, most of the stuff I've taken off today is going back in the garage.
That's
I'm
fine.
Fucking putting none of that back together.
Yeah, that's fine. Just put it in the garage. That way I can do what I gotta do.
Yeah, it's,
Alright, so
it'll be
let's see here. Yeah, I try to do that, you know, not just to protect the board, but to, you know, make it look a little bit nicer once everything's peeled off. You can only clean so much of the resin off that splatters off and what have you, so. Well, I hope so. I get mine from the same place that several people do, which is ICA, and it appears to always be good. No, it's far from being a midnight special. No, it's definitely not cut short by no means. You know, it goes, you know, from the front, well past the transistors themselves. You know, we're not trying to use a little, you know, quarter or half, you know, half little piece. You know, there's actually more than a substantial amount of heat sink there available for 2 transistors. Now, granted, I still wouldn't want to run this too god awful long without you know, some kind of cooling system, but yeah, it's able to dissipate enough heat for sure. See there again, I've got to reload the computer yet again as far as hit the refresh. Just so I can read my comments. Oh, mercy. That is correct, Mr. Black. The other side of that, too, is if you're dealing with Toshiba transistors, which I know you have bought many of those in your career, you know that it's basically $70 to $75 a pop. Uh, you want to make sure that they last a very long time. Yes, it is cheaper to melt beer cans. Yeah, transistors, even in the HG line, which I mean, I know we'll never see, you know, $15, $18 Toshibas ever again. Um, Not by any stretch of the imagination, which would be awesome. You know, I mean, if they would get down to that kind of price again, as far as a true quality transistor, um, that would make it actually a lot more affordable for those that are actually looking to get into the hobby. It would drop our price down considerably. And this is actually some really good thermal paste that I've been using. I actually found a generic that I like just as good as the Quicksilver. You know, this small little tube here cost about $30. This cost about 13. So huge difference on cost. I still do use this from time to time. Part of it is according to customers' choice. You know, if they want to get that crazed. I actually used to use a lot of silver solder whenever I actually built my amplifiers, and I actually had to give up and go back to lead because I couldn't compete with the cost. That, and everybody kept saying, well, why isn't yours as shiny as so and so's or what have you? You know, when you pay $118 a roll for a pound of solder versus $20 a roll, the cost is so astronomical. I don't think people realize that. Which I just actually started going back to lead here about 16 or 18 months ago. I went back to the 6040 rosin core lead solder, or what is it, 63, 37, something like that. But I actually just recently went back to that because of the cost. Now, I still use my silver solder, but I use it primarily just on radio repairs, whenever I'm doing radio repairs. And the reason why is because of the fact that it's a low temp silver solder. However, once it is heated up and soldered, the solder itself actually has a higher melting temperature point. And for some of the radios that actually wind up with what they call a cold solder joint, where it's just happened over time, where connections have lost or gotten failed because of just everyday use. Like I said, I use the silver solder in order to go ahead and make the initial repairs that are needed. All right, let me get some pill screws. Yeah, normally I go ahead and I mount the transistors before I do anything else. And this particular time I didn't, and the reason why was because I was waiting on another order to come in. And I didn't really want to break a set of 8 that I had. And here's another thing too that well, these still cost me a little bit, but nothing like the original screws that I used 10 years ago. I actually used to use a socket head number 440 to actually mount the transistors, and absolutely love using those. And the last time I actually had to buy some of those, I actually switched and went to a stainless steel. I still have the traditional, zinc coated as well, based on the repairs that I'm doing. That way I can always match up. Since those are used a lot of times. But on brand new builds, since I actually physically tap each one of my holes, I actually use a stainless screw. It's a little bit harder, and the nice thing about it is because it is just a little bit harder, you're less likely to damage the head of the screw, which I've seen some of these guys gorilla muscle those little screws in, thinking that, well, if you tighten it down a little tighter, it's going to do better on the transistor as far as transferring of heat. And that's actually not true. You have to remember you can only draw those down so far. If you want them any closer to the heat sink, you're physically going to have to wipe off any and all kind of thermal compound associated with putting them on the heat sink itself. One of the things that it puts me in mind of that I've tried explaining to people whenever they say that, whenever they are trying to understand it, is I know there are several people that actually use magnet mount antennas. And if it's ever rained and you've went out to your car the next day or 2 or 3 days later, and you have ever taken and lifted the magnet mount up and you have seen moisture underneath of there, it's kind of the same principle. Is the magnet not stuck? Absolutely. But it can still only go down so far, especially on a curvature, So with having your heatsink compound underneath of it, once that has been compressed, it can only go so far. All right, so those are down, not too tight, just nice and snug. Go ahead and set our tabs here for ground. I'm just rolling those down. I'm not trying to push them to the point where they break. My screwdriver is just slightly rounded on the edge, but it's not rounded as much as some people. I know some actually take essentially a screwdriver like this and they'll actually round the edge of it, which is actually a good idea. The other side of it too is if you're very careful whenever you seat those, like I said, You don't have to be an animal with them. You just have to take your time and be gentle. Let's see. Let's see. Yeah. Yeah, I know you've visited a few people that build amps as well. And yeah, you've seen the troubles that some of us have to do to get these transistors out. Yeah, it's almost funny that you say that, because I've seen times where I've spent an hour and a half trying to get one transistor out. Now, another thing too that I'm sure you guys have noticed is that I'm just soldering all the grounds down first, and then I'm going back to solder the others. The reason why I do that is, again, to take and lessen the amount of heat and stress that actually goes to each transistor. Again, it's another safety precaution, less likely that you'll actually damage the transistor. Yes, sir.
That crimper?
No, I did not. You said you were looking for one, and that's the reason why you went to Home Depot to pick one up.
I didn't know if he's going to pick one or order one anyways or not.
Eventually, I had planned on it, yes.
I'll go ahead and order one.
Okay. All right. Give me a second, guys. I'm going to get some miscellaneous parts. That way we can go ahead and put our output tune in. And I'm going to pull the book, because I can't remember what I use on a 4-pill as far as for my reference here. Then we're going to build the biasing circuit and install the biasing circuit. Alrighty. Kids today, guys. Kids today. It's absolutely insane. Absolutely insane. Yeah, the boy, he works third shift. He got off this morning around 7 o'clock, and he has yet to went to bed, so he is suffering from I don't know itis. Keep telling him to go to bed. Okay, so yeah, and the sad part of it is, guys, we actually have to keep a notebook like this on the HGs. Um, it seems like every so many months, some of the values change quite a bit, so we actually have to stay on top of that. So we know where we're at. Put that up there on the cabinet. If that's what we're using it for, we can still reutilize that a little bit later. Ha ha ha. Yeah. Well, like several of us around here, you know, we have this anti-pilfering device that works very well. There's always one usually within arm's reach. I figured you'd like that, Mr. Black. Well, unfortunately, and I'm not sure how old of a gentleman you are, Mr. Black, but I know as a kid growing up, I can actually still remember when you could go to bed and leave the front door wide open or unlocked. You never locked your car anywhere. You know, yeah, the good old days. It's just sad that the world has come to the point that it has. It really is. It's just like, used to on a quarter watt resistor, you could actually see what color your rings were on it. Once upon a time. Trying to get it turned to where I can see everything that I need to see, guys, as well. And to make it hopefully to where you can visibly see what I'm doing as well. So that's part of the reason why I keep turning the pallet as often as what I do. Alright. Well, each part we put on gets us that much closer. Alright. Now, let's see. Get that part all installed. Alright. Now we're going to go ahead and build circuitry for our biasing. Now you're going to notice what to do the biasing on this. I've been doing the biasing a little differently. I've actually looked at a lot of different designs over the last 6-8 months, and I've been playing with some of them, and it's actually going to be quite interesting. Oh, so you're up by Fort Hood. I'm actually familiar with that's at. Yeah, lady, feel good? Well, you'll have to tell her I said hello as well. Anyways, let me get the parts here so we can get that started. And I'll explain why I'm using some of the parts that I'm using versus some of the other traditional methods. I have those made. All right. other parts here while we're thinking of it too. Okay. Let's see if we're biasing. We got that. We got that. Okay. All right. Don't need one more thing. There it is. Alright, so we got that.
Let me go for that.
Okay. Alright. Let's get this cut and then I'll start explaining a little bit about the biasing, because like I said, I know people are probably already wondering. we got that cut, we can shut that noisy thing off. All right. Now, one of the things that you're going to notice is I'm not using one of the great big sand resistors. I'm using a 3-watt resistor instead of 10 or a 15. You know, so there's a huge difference in the physical size. The reason why large sandbars are used is because of where typically you're inducing as much as 14 to 15 volts typically through this resistor, and then it's being decoupled typically with your diode essentially at the end. And then at this point here is where your voltage reference for your finals or for your transistors are actually being taken, is right off of this point. Because of the fact that you have very low resistance that actually is transferred through here and then directly through the diode. Okay, well, you know that 12 volts going right to ground is a dead short, but if you actually use a calculator, you don't actually have to use a diode. Technically, you can use another resistor, although it's going to have to be of such a huge value, such as 15 to 25 watts going to ground. Basically, what you're doing is you're creating a type of voltage divider. The diode is nothing more than a type of resistor. The only difference is it doesn't allow anything to back up into it. This direction will allow for cross flow. Since we're dealing with DC current, that's really not an issue. So therefore, you could actually use a resistor instead of a diode, but you'd have to sit down and formulate the amount of it. Now, the other side of that, and one of the downfalls, is if you are in a mobile application or an application where the voltage is not, incredibly stable, replacing the diode with a resistor, you actually can increase the amount of bias that's going to the transform or to the transformers and then to the transistors, and actually cause damage. So that's the reason why most oftentimes you'll almost always see everybody use a diode instead. In this particular application, what I'm actually doing for the biasing, and apparently my computer is froze again. So we'll do another reset. So what we're doing actually here with our biasing circuit that I'm actually building is I'm actually decoupling the RF. I'm actually taking input RF and creating a DC signal. So, what we're doing is we're actually using, a capacitor or capacitors coming off of our input right to our biasing board that I'm building. Now, essentially what we're doing is we're using two other parts. We're using a choke and a resistor. Now, the choke actually is going to decouple a portion of the RF, and essentially what it amounts to is we are going to see more of the voltage side of it because of the fact that we're using a choke. So we're trying to decouple the RF that's going into the circuit through an inductor, because all we're looking for is the voltage. Now granted, there's still RF at this point. Okay, once it gets decoupled, it's actually going to go through a resistor that's nothing more than allowing us to help control a little bit more of the physical power, and then we're still using our diode. Now, because of the fact that we're using a diode, what we've actually essentially created is a half-wave rectifier. By doing it this way, we've actually created a half-wave rectifier, and that actually allows us to have our DC current at this point here. So because of the fact that instead of running 12 volts, we're basically down to 3, 4 volts of actual voltage. Um, we don't have to have such a huge resistor here in order to go ahead and compensate for the physical drain. Now, what's also nice is, I've ran this on several tests, and I've got several amplifiers that I've built this into so far, and they've been working very, very well. Now, the unique thing about the circuit is this circuit works very good on small applications. For example, a 1 pill, 2 pill, a 4 pill. A 5 pill is pretty much the limit, because at that point you have to start siphoning off so much of the RF into the circuit, and have it decoupled that it actually takes away from the physical power going into the circuit at that point. So, this is a great circuit. Works well for the small amplifiers. I've tried it in an 8 pill one time, and like I said, I had to increase the amount so exponentially in order to go back and refeed all the transistors, that it's not practical in an 8 pill application. The biggest that I've been able to get it to work and work as it should is a 5 pill configuration. So, that's pretty much where I've stopped. Now, what's also nice is because of the fact that the circuit is built with the components that's needed, it makes it a little more economical, monetarily wise. So I've actually readjusted my price on the smaller amplifiers on doing biasing. It actually also takes a heck of a lot less time. So, there's not really that many different components, but the cost of the large, sandbars in order to get the appropriate resistance, and believe it or not, the type of diode that you use. There's several different ones out there based on what your needs are. And I use I use about 3 different type of diodes based on which circuit I'm actually building and for what reason. And the reason why I use different diodes for different applications is simply for the fact that they react different to voltage, especially when you're doing a voltage divide. So I can also, if I need a little more biasing for the circuit, I can change the bias voltage that's required and then go back and trim it back as needed, just off of which diode's actually being used in the circuit. So we'll let that cool a little bit here on there, and go ahead and just put our components in place. Yeah, well, that's another thing too is uh, you do have thermal biasing. Speaking of which, I'm actually glad you said that. Reason why is because I want to pull out something and kind of want to show you since you've been hanging in there with me so good. This little device right here. Believe it or not, in theory, that is an idealistic component for biasing. It does its job, it does exactly what it's supposed to. Now, what's interesting, get the camera to focus a little bit, you're going to see right here in the corner. Of course, it's now decided to pop up comments here on the phone. Anyways, right here in the corner, you're going to see small SMT potentiometer. What's nice is it doesn't matter whether I've got 12 or 10, 11, 12 or 18 volts going into the input. The output remains the same, whatever you set it at here. Now, what's nice and bad all at the same time on this is the fact that this will only go down to about 3 volts, which is still too high for input biasing. But it does allow you to run it through a small circuit and control and stay stable in regards to voltage. Now, the problem that I ran into, because I've actually tested this and actually had to pull one out of the circuit. Now, one of two things happened to that, and I've got about 6 or 8 of those that I had purchased under the hopes and dreams that that would work. Now, that little circuit, believe it or not, is actually rated for 1.5 amps, which is hard to believe. And I thought that this would be, I thought that this was going to be the key in having a stable voltage, no matter what the temperature of the amplifier, what the scenario would be, because of the fact that it compensates for whatever voltage is going in. It compensates and stays the same. So that was one of those interesting little projects that I tried, and it worked well in a 2-pill application, which I was sitting there thinking, okay, well, what's the possibility of using this, in a larger format? I've only tested it out on a 2-pill, and it worked incredibly great for about 3 weeks. At the end of the 3 weeks, I noticed that the tuning on the amplifier had changed, which kind of saddened me. And what had happened, and the only conclusion that I can come up to, is this little circuit is not RF friendly. Because of the fact that you need to still place this relatively close to the transistor and keeping your wires short here, it still didn't perform. It performed for a very short time exactly as intended. Like I said, you still had to use a resistor, you still had to use a diode, but you could actually go down to 1 or 2 watt resistor in order to go ahead and control the voltage. 2 watt was actually better, but you could actually control the voltage a lot better as far as going to it. But like I said, the problem that I ran into is RF actually ate up the circuitry. Um, Now, I didn't try doing any kind of shielding or anything like that, and what have you. But at the same token, how far and how much work do you go in order to go ahead and compensate for something like that? So, we actually scrapped this idea, but I still have a few of these left. Um, Still trying to think of a good application to use those in. Like I said, it was an absolute great idea. The cost of these, and what I was really hoping on, and the only reason why you had to run the resistor and another diode in line with this module, even if you're shutting it on and off. Um, you could actually use smaller components. The cost of this, I think, wound up about $2. So very, very economical as far as on the overall. And like I said, what I liked about it was the fact that I could actually set, if I needed more biasing or less biasing, I could actually set and make sure that everything was just exactly, to spec. Because there again, even most of the stuff that I use is all 1% resistors. However, you can match diodes all you want, but whenever you put these into a circuit, you still don't know how they're going to act or react. You can get them close, and that's all you can really do. So, I went with another method. So, there again, just like everybody else, I've been looking for the silver lining that we hope one day to find. But it all comes down to the cost. Because unfortunately, this is a cost-driven application and world when we're building amplifiers for customers. I've lost sales because of the fact that I'm $10 higher than the next guy. I very, very seldom waver from my price, and part of it's the fact that I know that I go through and I actually match components. I've got different bins, and that's part of the reason why I've got so many bins, is I go through whenever I get orders in. Oftentimes I actually match them up. Some of them go into baggies, and some of them go right directly onto the shelf. But the components are actually matched. Granted, I don't sit down whenever I order 1,000 diodes and match 1,000 diodes at one time. I just ain't got that much time not to devote at one time. So, whenever I pull out of the bins, the parts are most generally matched, as far as on things where I have to have matching capacitors. For example, your metal clad micas. I typically, even though they're 1% that I order, I still go back and I match those up to where they're nearly perfect. Same thing with my silver micas. They're matched to a 1% tolerance or less. Even though they say 5%, they're still matched within that parameters. Same thing with your input. These are the components that you're using the most of. So, those are, and I've found that it's very critical, more so now, using the HGs, to actually make sure that all your components are so closely matched, so that you have the least amount of problems with them. These transistors just don't act or react the same as a traditional Toshiba. before we go any further, I'll go ahead and clean some of this flux that has leaked out. The reason why is because with it, it still draws microscopic particles of lead, tin, into the mixture. It can do one of two things. It can actually act as a capacitor, or it can act as a dead short in an amplifier. Alright. Now comes all the goodies. That is exactly right, Mr. Black. You know, if you need more power, buy a bigger box. So oftentimes, so many people actually buy an amplifier because of the fact that, you know, their neighbor has pushed theirs so far to the extreme, you know, that they're getting, you know, for example, we'll use an 8 pill because an 8 pill has became kind of the standard anymore for a lot of guys to run. And, you know, you'll see an average of anywhere from 7 to 800 watts RMS going out of the amplifier. Well, that's perfectly fine. Now, granted, I know that the transistors are rated at 100 watts, but in most cases, if you actually go back and look, just because your car can run, or it's measured on the speedo to be able to do 160 miles an hour. Now, obviously, there's a couple things there when you're dealing with a car. You know, 160 miles an hour. All right, well, that sounds like a ticket waiting to happen if you're on the open road. Can the car do it? Yes. Now, the other side of that too is, can the car sustain that kind of abuse day in, day out, hours on end? No. Typically the cars are ran at anywhere from 50 to 80% duty cycle, essentially, as far as for your everyday performance. So, you know, with that in mind, you know, I think everybody pushes their boxes sometimes just a little too hard. You know, if you're doing nominally, you know, just normal talking, if you're doing a nominal, you know, 650 to 700 out of a, 650 to 700, you know, out of an 8 pill that's designed for 800 RMS. Really and truly, I think that's where you should be running it out, just simply because of the fact that it's going to last a little bit longer in the overall. You know, I've seen these 4 pills. You know, I've been seeing close to 500 watts bird coming out of these 4 pills. Nominally, you know, between 350 is actually a good number to run these at. Mainly because of the fact that you're not pushing them to the limit itself. to me, you need to leave at least 10 or 20% margin for the amplifier to actually breathe if you want it to last for an incredibly long time. Um, and it's getting hard for people to want to run them at that level, but at the same time, people are whenever you talk to Sheba. Why? Because of the fact that they want to baby them, they want the amplifiers to last for the next 20 years. Um, Now, granted, you're looking at with the HGs right now, our cost on them's roughly around $30 a piece. You can pick a pair of them up for $30 a piece on eBay. Okay, $30 a piece doesn't sound bad, but whenever you start multiplying that times 2, times 4, times 8, 12, or 16, that gets into a significant amount of money. So why do you want to sit there and push things right to that edge? If you're looking for more power than what you currently have, that's exactly what you want to do. Go to a larger box. Save the money. Save the money, and don't blow your transistors up, because that costs a lot of money, especially whenever you send it in. You have somebody go through the circuit to check everything out, to pull the capacitors to make sure that none of those have dropped too far out of tolerance, replace the bad transistors, to go back and potentially retune the circuit as far as on your input and output in order to go ahead and make your box run. It's just more affordable in the long run to go ahead and just go to the next size. If 1,000 isn't doing you, okay, well, consider what you really and truly are looking to achieve, and talk to your builder, whoever that may be. Talk to your builder about, okay, these are the numbers that I really and truly want to achieve. What can I do, where I can buy such and such box, whether it be, transistors or tube type, so that you don't have to push everything right to that, right to the brink of destruction. Because, after all, everything's going up except for our wages, guys. Yes, headroom. Headroom is key. And I hate my computer, guys. But yes, headroom is definitely key. It's just like on power supplies. I try to allow a little extra on headroom whenever I'm building power supplies as well. Why? Because if I sell you a 500 amp power supply, I want to know that I've got enough capacitance in there to where if you need to run it at 500 amps, you can run it at 500 amps. Obviously, with anything you buy, please allow yourself headroom. Rule of thumb is 20%. If you're an extremist, still allow yourself at least 10% headroom. If you're going to run it to the extreme, but just make sure you allow something in there for headroom. Oh yeah, yeah. We've got some guy. I'm wondering whether or not you ever hear him out there. He actually goes by Timex. He's down in Kentucky. I know for years and years and years, he has been running a station nonstop, and God, I would love to have the money that he has spent on repairs, just in repairs, because he keeps 2 boxes continuously fixed that, if the system goes down, he actually goes back and rebuilds it again, and puts the other one in line until the other one's fixed, just so that he can play music. And he does that continuously just because he has a grudge against one individual. Yeah, yeah, 500 amps is 350. Even pushing it to 4. Uh, Again, like I said, it's allowing for that headroom. Now, one of the things that I've actually started doing, speaking of headroom, which I actually have slowly, I've got just a few of them left. When they're gone, I will probably quit using 30 amp switchers. I've actually started building a lot more with 40 amp switchers. They are a little more expensive, but I base everything as if I was building 30 amp switchers. To allow for extra headroom. But I've been building a lot of stuff with 40 and 50 amp switchers. 50 amp switchers I've been doing for quite some time, and here just in the last I'm gonna say the last 3 months, I've actually been building a lot more with 40 amp. Mainly because of the fact that it does allow for a little more headroom on my end. There again, it's a little more expense, but you get a lot more. You get a lot more bang for the buck. I've got prices for power supplies online, and those prices do reflect the fact that I'm using 40 amp switchers in them instead of traditional 30 amp. I'd love to use the Meanwell, but the Meanwell 100 amp power supplies, because the cost, they're not cost effective. Are they worth the money? Absolutely. But I can build 3 times the power supply for a third the cost. Rip his tower down. Yeah, that would be a wonderful thing. It really would. Just debating on which way I want to put this because of components. Because now what's also nice about this circuit is I can actually set this up to where it's biased all the time, whether it's on AM or sideband, which I believe that's what I'm going to do. I've changed my mind like 3 times on this build. There you go. Absolutely nothing wrong with that. Mr. Adams, are you still in there, big guy? Have you popped back in yet? I haven't seen you comment for a while. Well, Mr. Black, since you're in there, let me ask you this. What is your take, since I've kind of explained what I'm doing here with the type of biasing circuit that I'm building? What do you take from that? Eating donuts. Yeah, you're always eating something. You're the donut man. You're the guy that builds the cheeseburger with donuts on top and bottom. Yeah, I'll look at the comments here in just a second. I get this part here put in. Yeah, guys, it really helps as far as on the comments from time to time, or questions as I go along. Reason why is because it gives me something to be able to talk to you about while I'm building. Believe it or not, it is incredibly good because of the fact that we're able to go back and not talk just about miscellaneous things, but you know, we can kind of try to stay on target with what we're building and actually be able to explain part of the work as we go along. Because I know a lot of people are out here, you know, they're wanting to try different things. You know, I've got a couple of students myself. There again, I'm a student, or I have a mentor, if you will, that I speak with from time to time that helps me out when I need it. And you know, I've always tried to do that over the last 20 plus years as far as on radio repair and stuff. You know, but I try to give back as much as I can, and I know I've had some slow, I wished I had more slow time, but I still try to take time with some of them. There's a couple people, one of which I know is watching. I will actually do just what I'm doing right here and go back, and in some cases we'll do video chat and talk back and forth while I'm actually working, and that way I can kind of monitor and see what they're doing as far as with their work at their stations, and help them whenever they've got questions. Some people are doing amplifiers, some people are doing radios. Like I said, I'm more than happy to help anybody that's trying to learn or build something. It's just like, I thought it was interesting. I had a comment, and I haven't had any calls yet over it, but I had a comment, and a gentleman that spoke with 4 or 5 times in regards to one of the videos that I put up, which is something as simple as putting in an echo board. Now, granted, there's some of us that haven't done it in 15, 20 years or longer. Some of us have, but there's always somebody new out there that they don't really have the money to send it into the shop, and they want some experience, and that's a great way to go. I've got a couple students that have asked for more information on different things, and that's why I've been trying to actually do some of the different videos that I have in relationship to information. Thank you for saving the hobby. Well, I do my best. I know I've noticed, especially in the last 15 years, the degrade on the amount of people. Plus, we've had a lot of the older people that have passed away, and that makes a big difference as well. Hello, Bruce. I see you decided to pop in too. Okay, so do you think the HG 2879s will work for my 24 build project? Yeah, actually I do, Bruce. They've been out now long enough that there's been a huge amount of new development, I think, with the transistors. I've talked to several other builders, and we're not having as much of an erratic change in venue with the transistors as what we once did when we first all started. Some of them didn't want to admit it, some of them did, but yeah, I think you would be okay at this stage now to consider the HG 2879s. Now, the other side of that too is, I know you're one of those that we were just talking about, essentially, where you are, you're trying to learn, about the hobby, not that you actually want, not that you want my job, by no means, but I've seen multiple times where, money is, money is an issue, so, those of us that don't have it, have to learn how to build for ourselves. So, wow, guys, over 3 hours. I didn't realize I'd been out here doing this that long. I'll tell you what, we're gonna get these last 2 wires here hooked up. I think I am gonna go fix me some dinner, come back, and if any of you would like to actually continue this with me, send me a message. If you're on my Facebook, give me a thumbs up on the post as far as where we started at roughly 5:30 this evening, here in Indiana. If you would just comment on that or comment here, I'll go back and I'm going to take a look at some of it and kind of go from that point. But if you guys would like to see the finish of this, I plan on being here all night regardless. So for those of you that would like to see it, let me know, and I'll come back and restart this video. But I want to definitely get some lunch and go from that point forward. So, alright guys, I appreciate it. Like I said, you've all been great, you've all been wonderful, appreciate the interaction with you guys this evening. So, like I said, we're going to go ahead and take a pause. I'll go ahead and shut this video off, and we're going to go back to this shortly after I eat my dinner. So, yeah, 24 pill Toshiba. Yeah, plus the shipping. Oof. Yeah. Well, hopefully, if my box ever gets back from the painters, which I've got, I've got parts already here for that. I'm going to be building myself a beautiful little 16 pill amplifier. It is going to be a mobile case, but I'm going to use it here here in the shop. But that one, guys, I think you'll like that one whenever I finally get to start on that. That will be kind of a slow process, but I do want to get it started, because whenever I get it started, I think you guys are going to really like it. It's going to have some very unique traits, is the best way I can put it. So, everybody, like I said, love y'all. I appreciate you for the interaction, and we will get with you later on this evening. All right, guys, take care.